I really need to put the Chevelle on the lift that the 69 Trans Am project is on, but I can't stop working on it either. I wish somebody made some tall jack stands with wheels. Then I could work on both projects. I think I have an answer for that. My solution is 4 of these 1,250-pound swivel toolbox casters for a total working weight of 5,000 pounds. These will be attached to some extension tubing and then bolted to the frame of the 69. This will keep it at a much taller working height and make it totally mobile. My goal is to keep the car about this high. I'm going to use 3/16 thick square tubing for this project, 2.5 inch square for the front and 2x3 for the rear. Determine the length of the extension tube and the size of the caster mounting pads. I'm making my extension tubing 14.5 inches and the pads are 3/16 inch flat plate that I cut to 4 inch by 4.5 inches. The caster wheels are a little over 7 inches tall, so that puts the car up about 22 inches high. Center punch and drill mounting holes in the caster plates. I'm using 3/8 bolts. In preparation for welding, it definitely helps to grind the mill scale off, especially on hot rolled plate and tubing like this. Warning: read and follow all labels and your owner's manuals. For welding the caster mounting plates to the extension tubes, I auto set my Multimatic 220 AC/DC for 3/16. Now I'm not welding all the way around the tube. I'm only putting about 1.5 to 2 inch weld on each side. That should be plenty for this application. I'm using 030 size Hobart ER70S6 wire and just regular 75-25 argon CO2 gas. Okay, in trying to figure out how I want to mount this to the frame, I figured out that the best thing for me to do is take that same 3/16 plate that I made the mounting pads out of and make a saddle that's going to go right around the frame rail, and then I'm going to drill a 7/16 hole through both the saddle and the frame and just run this through bolt through it. So that should easily be enough to hold this to the frame. Okay, this part of the frame isn't perfectly square. There's a transition from where the frame is vertical to where it transitions to wider and horizontal. So I'm going to have to cut my mounting plate a little at an angle on one side. Okay, I tacked the plates up into position on the frame. Now let's just remove it and finish welding it. The radius of the frame here is actually quite large, so if I wanted to, I could just put my weld beads on the inside of the saddle and it shouldn't interfere with the frame at all. Remember, keep grinding off your mill scale. Now let's drill our 7/16 hole through the saddle and the frame. All right, I got my saddle up into position again, and I've got my holes marked where I need to drill my 7/16 hole, but I'm running a small pilot drill bit first, then I'll take it all apart and drill my 7/16 hole. Perfect. All right, I'm stepping my holes up 3 steps before I get right all the way up to 7/16. Okay, let's check this out. Tight. I think that's gonna work good. I'll finish drilling the other side and work on the back ones. So the frame mounts for the rear are gonna have to be different. The back frame isn't nearly as wide or thick as the front, which is why I'm using this 2x3 square tubing. So this is what I'm gonna have to do. Check it out. All right, so you can see that the rear frame is much narrower than the front. So what I'm gonna do is making my own angle piece that will fit around this and attach through an existing hole that already has a nut fastener in it. And then we'll drill a hole in the side and insert one of these riv nuts that will secure that plate to this frame. Now I know what you're thinking is, why not just use angle iron? Well, angle iron has a wider radius and this frame has a nice tight bend to it, so the angle iron won't sit nice and flat to the side of the bottom. It's going to end up rocking on this corner bend, so that's really not going to be an option. So we're basically just going to use that same 3/16 plate that we made the front stuff out of. Okay, I plan to TIG weld these corners instead of MIG weld them. Could you MIG weld them? Sure. I don't think that'd be a problem at all. I'm more of a TIG guy. I got my Multimatic 220 AC/DC set for DC TIG steel, and it's auto set for 3/16. Although I did fine tune it up a little bit higher, which I'm managing with the foot pedal. Wonderful. I'll just leave that sit there on the fixture for a little bit, and that'll help keep it from warping. Okay, this next part for me is kind of critical and kind of not. The critical part is I need to locate this hole exactly because it has one of those frame clip nuts in it. So what I did was I marked halfway through the hole on the front side, halfway through the hole on the side, and I transferred those marks to my piece, and the intersect point is going to be where I'm going to drill my hole. Now the side hole isn't that critical and I can make it anywhere. I'm going to make mine about 1 1/4 inches from the top and 1 3/4 inches from the back. I'm going to drill that with an 1/8 inch pilot hole through the side of my plate and through the frame. That is going to be the location for my riv nut. All right, now just paint it your favorite color, as long as it's Miller blue. That ain't going anywhere. Time to assemble these things and bolt them in the car. Now this same concept will work with many different types of vehicles. Really the only difference is how are you going to mount it to the frame. Plenty of room to get the other car in. And still at a good working height.